So today we're going to focus on two special triangles, the isosceles triangle and the equilateral triangle. You remember that an isosceles triangle has two equal sides, right? So now we're going to say, well, these two equal sides actually have a name. They're called the legs of the triangle. So the legs of an isosceles triangle are the two equal sides. The base is kind of what I call the other side. Seems like it would always be the bottom, but sometimes the triangle is turned. So here, like in this one, that's actually the base, right? And the other two equal sides are the legs. The base angles are the angles near the base. And you can see those on the picture, angles near the base. So like there's the base angles here, or here's the base angles here. And then the vertex angle is like the other angle. The other angle. So a lot of times it's at the top. It's not always at the top, but if it's at the top, it seems like it makes a little bit of sense here, like the vertex angle's up here, but here the vertex angle's over there. Here's the big rule. If two sides of a triangle are congruent, then two angles are congruent. Or we say two equal sides means two equal angles. Similarly, two equal angles, then you get two equal sides. And the equal angles and the equal sides are across from each other. Or you'll hear me say a lot that the equal sides point to the equal angles. The equal sides here kind of point to the equal angles. They're across from each other. Make a little more sense when we do an example. So if we look at number 1, it's telling us to use the symbols here. The equal sides are the legs, so that's side JL and side KL. Those are the legs. Where the base is like the other side, JK. The base angles and the vertex angle is angle L. Vertex angle is always between the two equal sides. And then the equal sides will point to the base angles, angle J and angle K, which are equal to each other. Trying again with number 2 here, PQ and PR, those are the equal sides, so those are the legs, PQ and PR, making the other side, QR, the base. And then if I do the vertex angle, it would be angle P, kind of between the two equal sides, and then the equal sides point to the equal angles, angle Q, angle R. This is just focusing on that idea that equal sides are across from equal angles, so the Y is going to be 50 degrees. Those two will match each other, 50 and 50. They keep moving that equal side around, so like here and here makes angle F 65. And if I want to find angle G, 65 and 65, that adds up to 130. So if I subtract that from 180, I get 50 degrees. A question like number 5 often gives people trouble. It's either going to be 12 or 13. How you can find out is you go across from the equal angles to see the equal sides. So the x is 12, across from. Similarly here, if I go across from the equal angles, I get my two equal sides. The 4x plus 4 is 32. And if I solve this, I'm going to get x equals 7. Divide both sides by 4. So that's equilateral triangles. Or sorry, that's isosceles. Equilateral triangles are even easier, right? Because they're 3 equal sides. And then we also learned it always goes with 3 equal angles. Or I say my little song, 3 equal sides means 3 equal angles. If it's equilateral, then it's equiangular. And if it's equiangular, then it's equilateral. 3 equal sides means 3 equal angles. How many degrees, by the way, is every angle in an equilateral, equiangular triangle? Right, we did that before. It's 60, right? So here in number 7, once I see those are equal all around, then it's got to be 60, 60, 60 all around. Or like in number 8, once I see that it's 60, 60, 60, then the sides have to all be equal 4, 4, 4. It's nice, equilateral, everything's equal, right? All those are equal, so the 3x is equal to the 2x plus 10. Or if I subtract 2x from both sides, x equals 10. So the equilateral questions are always easier because everything's equal, right? So we have isosceles and equilateral.